Cool. Hi, everyone. I don't think I've been in a lecture theatre for about 10 years, so this is interesting. So yeah, if I feel unnatural in here, yeah, I guess I better just get used to it. But yeah, as Nick said, I'm Dave Buckley. I work for the Centre for Data Ethics and Innovation, also a member of the United Nations Privacy Task Team. So I guess I'm here in my CDEI role. So who are the CDEI? So we're basically part of the UK government, and our kind of remit is to advise government on how to responsibly use data-driven technology, AI, whatever other buzzword you want to throw in there. So it's quite a broad remit, I suppose. But yeah, I'm going to talk a bit specifically today, I suppose, about some work we've recently done that Nick alluded to, running this Privacy Enhancing Technologies Challenge Prize. So kind of going to go through, so I know some people in the room were kind of directly involved in it, so probably understand the nitty gritty of it more than I do. But I'll kind of give an overview of the project, like the motivations, and then some lessons learned from running what has been, yeah, a sometimes complex and difficult process. But yeah, as I said, sort of CDI, we work to facilitate responsible, interested innovation. And we have kind of a separate work stream all around public trust as well. So sort of how do you engage with the public where there's all this sort of technological change that's happening, which is very kind of, prescient at the moment, with all the hype around sort of large language models, etc. So how do we kind of make sure innovation happens in a trustworthy way that kind of engenders trust and kind of leads to good outcomes, etc. So kind of some context for, I guess, the specific work I'm going to talk about. So we recently ran a survey with industry where, yeah, kind of the majority of vendors have sort of highlighted data availability and fragmentation as barriers to innovation. So I guess the idea here is there's a lot of valuable data in the world, but we're not sort of making the most of it. And kind of part of that is there's kind of the innovation stifling impact of that potentially, but then also this idea around sort of more ethical issues. If you think about sort of bias in algorithms, so we published like a major report on sort of algorithmic bias a couple of years ago. One of the major blockers that you get from sort of companies trying to tackle this problem is they don't have the sort of demographic data to be able to kind of measure bias in their systems, let alone mitigate it. And that's for sort of a variety of reasons, some of them legal or kind of perceived legal reasons, etc. So yeah, but fundamentally it comes down to a data access challenge. So I guess it's kind of we've basically set up this program of work, which we call Responsible Data Access, which is all about tackling kind of challenges in this space. So I guess the kind of high level take here is that at a sort of macroeconomic architectural level, you could say that like our current ecosystem of information flows, information sharing is sort of suboptimal on a lot of dimensions. Like we don't get that innovation, as much innovation as we might want. At the same time, online privacy is becoming a more and more, important problem. And nobody really knows sort of what happens to their personal data, etc. once they've shared it. And the only real control you have, is like the dreaded cookie banner. Which I would not, I don't think anyone would really agree that gives you particularly meaningful privacy. So we kind of think we can do better. And this is where I guess the work on sort of privacy enhancing tech comes in. So we have this idea that maybe these sort of emerging technologies that I guess you're all talking about today can perhaps help change some of the incentive structures so that we can build this sort of data economy that works for everybody. You're probably all cringing at like the oversimplification of this slide, but this is idea that we have these sort of new technologies that essentially allow us to, have more privacy at the same time as having more utility from data. This is how you sell things to policymakers. Cool. So this led to this PETS Prize Challenge, which Nick mentioned. So this started maybe about 18 months ago, and has been a collaboration between so ourselves, sort of leading things on the UK side, and then on the US with the White House Office for Science and Technology Policy, the National Science Foundation, and NIST, so the National Institute for Standards and Technology. And then we ultimately ended up sort of partnering with SWIFT, who are like the International Payments Network, and so the University of Virginia's Biocomplexity Institute, who sort of provided the data sets for the 2 tracks and the challenge. And then finally, there was this partner, Driven Data, who kind of built the infrastructure and platform that, the challenge kind of ran on. So I guess, the goals for the challenge originally. So we wanted to drive technological innovation in state-of-the-art privacy-enhancing technologies, develop solutions that deliver strong end-to-end privacy guarantees against a set of common threats and privacy attacks, and at the same time, develop solutions that can generate sort of high-quality machine learning models. So I guess the question is then, like, why privacy-preserving federated learning? We did a bunch of engagement, I suppose, at the start of the challenge, sort of researchers, academics, people in industry, etc., and kind of got feedback that this would be an interesting space to explore. I guess, like, there's an increasing amount of sort of federated solution deployments. I think there's sort of ongoing research into kind of the end-to-end privacy that you might get out of some of those implementations. So it was, I guess, one of the aspects we wanted to tackle here is, like, how can you have provable privacy across sort of the whole machine learning lifecycle? And then sort of other things around, sort of cross-device federated learning was perhaps more common, but like cross-silo a bit more rare. And that solutions, I guess, are often quite bespoke and not that adaptable to different machine learning algorithms, different modalities of data, or different use cases. So there was all these kind of things that we kind of wanted to try and tackle in some way. So this is kind of the opportunity, I guess, that we had. So we want to encourage innovation that can bring about efficient, performant, adaptable federated learning solutions. So as Nick said, we had these 2 tracks in the end. So I guess part of the challenge is we wanted to not only drive the technological innovation, but be able to showcase through kind of using quite realistic examples, like what the benefits, the sort of societal benefits, etc., can be from using these systems. So we ended up with a use case in health, a use case in finance, which I kind of described there. But fundamentally, the financial crime one which I think the Cambridge team and the Privitar team who were in the room both entered, was around sort of data sets provided by Swift. So they have sort of data set with essentially every row is like a transaction between 2 points on your payments network. And can you sort of join that data with that of other financial institutions like banks, etc., who have more information on sort of specific accounts in order to develop a model that's better at detecting financial anomalies going through the system. And then we had this second track around pandemic forecasting, which was, essentially inspired by recent world events, but a synthetic data population where you essentially have health and mobility data segregated across different, say, like NHS districts, it might be in the UK, or in general, kind of arbitrary health districts. And how can you join that? How can you use that data in order to better predict how, like, infection from a disease, etc., propagates through the population? And we have this kind of structure. So teams submitted this white paper, so where they kind of outline their technical solution. Certain teams, the teams that were judged to have written the best white papers were given funding to then develop those solutions. And then, those solutions were kind of submitted. And then we had this red teaming phase where adversarial teams came in, sort of launched privacy attacks against the solutions. So, this is a nice little demo, I guess, of kind of the high level Swift federated learning scenario. So you kind of have Swift, there's a Swift data science team, and then a bunch of banks, and then also this Swift operations team. This is meant to signify that even internally at Swift, right, the data science team can't access a lot of the data that other parts of the organization have. So they kind of do federated learning all like this on this model. And then, I guess some of the challenges trying to highlight here, right? So you've got the vertical partitioning between like the banks and Swift. So do you need some kind of cryptography to be able to do the data linking there in a privacy preserving way? And then, there's privacy leakage. So a sort of weights being communicated back to your central server. How can you protect that from sort of reverse engineering? You guys all know much more about this than I do. And then the same question, I guess, for the final model that you produce. So there's some information about submissions. So we had a lot of submissions. Ultimately ended up with 19 solutions being built across the 2 tracks. And we had this demo day in London last week, where we kind of showcased quite a few of those, which was very fun. And I guess, yeah, some takeaways here. So this is kind of the rate, I think this is just from the US side of the competition. But these are kind of examples of some of the different technologies teams were deploying. I guess it's interesting that most teams were kind of, well, like differential privacy, I guess, has become the sort of de facto standard for protecting like output privacy. Yeah, kind of interesting combination of different technologies, different approaches to the kind of modeling task, etc. Which I think for what was quite a narrowly defined use case that we were posing participants, it's quite interesting, like still like the space of solutions that people came up with was still quite large. Cool. I'm going to talk a bit about then the design of the challenge, particularly the evaluation environment, because I think that's where the more interesting lessons learned are. And I'll try to do this quickly because I guess we're a bit short of time. But yeah, we wanted so I think the hard part of this is, right, you set these problems, you ask teams to go and develop concepts and to build solutions. And it's like, we have this prize pool of money that I think was like $1.6 million or something. And it's like, how do you sort of fairly judge teams based on their solutions? Turns out it's really hard to do. So we sort of ended up, what we wanted to do was to have an evaluation environment so a common evaluation environment. So teams could essentially submit their code there, and there'd be a kind of framework and a sort of shared API that teams would have to adhere to. And you'd sort of get automated test harnesses running, and you would get some metrics that could inform the evaluation. So yeah, we ended up using the Flower framework for that. Hence the relevance to this conference, I suppose. I think that was chosen because of the sort of, it was like the most mature and kind of flexible framework available at the time. The intention kind of was, if we can like enable teams to focus their attention on the more like privacy preserving aspect, and try and take care of some of the like the underlying sort of communications part, and provide that kind of common API and like accompanying primitives, that will make implementation easier. So yeah, Driven Data, who we're working with, kind of developed this framework and kind of published all the information about the API, etc., that teams had to use. And yeah, that's kind of technical details, which I guess aren't really that interesting. But yeah, we kind of, again, the challenge with federated learning, I guess, is like how do you emulate that, and not spend a huge amount of money on kind of physical infrastructure, etc. So we kind of, yeah, use like essentially a simulated federated learning thing. Yeah, simulated using multiprocessing. Cool. And all like the framework, etc., that's been built is kind of open sourced online, so you can dive into it if it's of interest. So yeah, I guess an important thing here is like this was maybe one of the first lessons, is like there's trade-offs involved, right? So we could have left it completely open and say teams go and like do whatever you want, use whatever frameworks you want, etc. But then we would have had no common way of like measuring different metrics and like having. So we could let teams self-report, but then how do you actually, how are you certain that they're telling the truth, basically? So it puts a lot more weight on like having expert judges and assessors who are able to potentially go and understand a bunch of different technologies. So we kind of ultimately made this decision to go with this Flower framework. And yeah, I guess it just meant that like as we went on, because there was a problem here was that we'd like, using this framework was kind of, it happened, that decision was made like in the middle of the challenge to some extent. So yeah, I think some teams, probably not the ones in this room, I guess, but some teams, yeah, sort of had to, felt somewhat constrained, I guess, because they hadn't designed their solution with this kind of framework in mind. So there was kind of a lot of support that had to happen to participants, and kind of things that had to be added on to help people get their solutions to work. But in the end, I think it worked out pretty well. Okay, here's my big long list of lessons learned. I'm just going to whiz through these. So finding data is hard. So yeah, just identifying interesting data sets in health and finance, once we decided those are the sectors we wanted to focus on, was like challenging. Like you need to know the right people. And even then, so we managed to get in contact with Swift and UVA, who were generating these synthetic data sets. But then they were sort of doing that at very short notice because we had quite tight timelines. And then, yeah, like there ended up being quite a lot of data quality issues, I think, just from problems with the data generation process, which again, I think kind of worked out eventually, but was a bit frustrating maybe to participants. I think it's also then, it's kind of hard to know ahead of time if the use case and data set is like amenable to federated learning. So I guess both data sets in this challenge were like highly imbalanced. So you mostly have outliers, right? So most people don't get the disease. Most people aren't committing fraudulent transactions, fortunately. So it makes it quite difficult to, do this kind of privacy reserve and federated learning approach. Because I guess with like differential privacy, like fundamentally you're trying to bring outliers closer to the mean. So yeah, I don't know, it becomes very difficult. And I think, some of the participants kind of, fed back on that. And then the data sets themselves are quite big, especially the health one. So I think it was like a population of like 8 million people. This was based on the state of Virginia. And that, some teams training time was like a day. And originally we planned to use a UK equivalent, which would have been like 60 million people. But yeah, thankfully we decided not to do that because God knows how long training would have took and how much our kind of server bills would have been. And then I guess, evaluations, I think this is really hard. So like, as I said, sort of before, specifying a framework did constrain some teams. But on the flip side, if we hadn't done that, and that's like any framework we would have chosen to use, right? We would have had the same problems. But it at least gave us some kind of objective, kind of common metrics, which we could use to assess some of like the privacy and accuracy scores, etc. I guess I'd emphasize that sort of fundamental trade-off, which is like the simplicity of evaluation versus giving participants like complete flexibility over what they choose to implement. And I think it's also worth emphasizing there. So like we'd have these metrics, but they weren't really enough to do the final scoring because there's only certain things you can measure. So we had like a panel of experts who like use those metrics and like reports that teams have written to ultimately come to a decision on who the final winners should be. But yeah, I guess because we were trying to include a lot of criteria like privacy, accuracy, efficiency, like scalability, adaptability, like could this generalize with the use cases? You need quite a lot of expertise, I think, to be able to do that. And when you're asking assessors to do this kind of voluntarily, it's quite difficult to maybe get the time and effort that's required. And I guess the final thing here as well to note is this red teaming phase. So we were really excited about that phase. And I think it's a really important area, like how I think there's probably a lot to learn from like cybersecurity, right? Where if you really want to prove like the privacy guarantees of these systems, like we need to be able to test them. I don't know if this is like reflective of like the sort of state of that industry, so to call it, or not. But yeah, we found it really difficult to recruit red teams. And they only had a limited time. I think they had like a 4-week period essentially to launch attacks, which wasn't a huge amount of time. But yeah, I think it's an area where we're keen to do more work. And I think also with the time they had, there was, again, because we were trying to drive innovation here. So like the solutions people were building were not like finished products. So sort of testing cyber like implementation. So some of the red team attacks basically sort of, they called out what were essentially issues in implementation rather than issues in like the privacy design itself. And yeah, if we'd have been able to factor that in a bit better, that might have been helpful. Cool. I'm probably getting way over time on it, but I've got like 2 more slides, which I'll just run through. But yeah, main takeaways. Running a privacy tech challenge is really hard. Interesting kind of working with US government and different US agencies. This is more a personal reflection. But I think like initially that was quite difficult, even on the US side, when you have these different agencies who don't really talk to each other, it means things take a long time. But I think in the end, it's been like a really powerful vehicle for like getting momentum behind the challenges, etc. I was talking about before, a breadth of solutions. And the final submissions were of like genuinely really high quality. Like our assessors were super impressed by all the work had been done. So yeah, well done to the people in the room that applies to. And then I think, this final point here. So as I said, we had this demo day in London last week. And I think that was quite an exciting opportunity to just get all these people together. It's like policymakers are talking about this stuff, regulators are talking about this stuff. potential adopters, and obviously the tech community as well, and getting them to talk to each other more seems super, super helpful. So maybe we should do that more often. And here you guys are. The final point I'm going to make is that government are really interested in pets. So yeah, like the US recently published a government strategy on pets, although they call them like privacy preserving data sharing methods or something, which isn't as fun an acronym. But yeah, then the United Nations Pet Lab has developed kind of infrastructure for doing essentially like privacy preserving analysis across different national statistics offices. The OECD recently published a report on a kind of planning convening activities around this work. Regulators in the UK are very interested. You've seen, might have seen the Information Commissioner's Office has published regulatory guidance on the use of privacy enhancing technologies. And then, yeah, like the UK government, which I guess I'm a representative of today, are scoping a lot more work in this space. So we're looking to address barriers to adoption, and kind of also think about how government itself can be like an early adopter of some of these technologies. So yeah, if you've basically got any ideas of what government should be doing, please get in touch. Well, there you go, and you can get in touch like that. But yeah, if there's time for questions, happy to take them or speak after. But yeah, thanks.